Before we set up the volume and temperature relationship, Charles law, I'm just going to show the problem with this setup. What we've got here is an incredibly leaky syringe. You see, we can pull the piston back, and you definitely shouldn't be able to do it. We can push it forward. There's no way you should be able to do that. So we have a problem with this setup here. We're definitely missing some of the air. So we have a better syringe that we're going to swap it with. This is demonstrated just here. We can see now that we block the end of the tube off. We really can't pull the piston back through the cylinder in the syringe, and we definitely can't push it one way or the other. So that's the effect we want to see on this one here. So we're going to swap these round, set the experiment up again, and then we'll come back when we start doing the heating effect. We've swapped the syringe now, and we see the difference. As we pull it back, there's just no way you can pull that piston back in the syringe. It's always going to go back to its zero position effectively. So now we know that any expansion of the gas here is going to go up through the tube, is going to push that piston back, we're going to see an increase in the volume. So now we're just going to put this into the water bath here. Again, gentle heating. We want to make sure that the air temperature in there is nice and stabilised. We don't want to have a roaring blue flame here and everything heats up too quickly. We're going to heat it quite gently. Improvement on the last experiment though is that now we are actually measuring the air temperature directly as opposed to measuring the water temperature, which we're assuming was the same as the air temperature. Okay, so we're going to set this up, we'll generate some data and get those results to you.
What did it say here?
The volume marked on 0, that's it? Yes.
Oh, okay, wonderful.
Okay, so here we can clearly see the expansion of the gas, and we see that the piston inside the syringe has been pushed backwards, and we're reading the change of volume, the delta V, onto scale on the side. But with the heating removed, we still have some thermal expansion. The water is still warm. It's warmer than the air inside the flask, and that's still causing the gas to expand, even though the heat has been removed. A little while after we switch the heating off, and you can clearly see that the volume is reducing. So eventually, at some point in the future, that is going to go all the way back down to zero again and return to its original volume.